are at the beginning of Module 2, and Module 2 is going to deal primarily with linear functions. So remember, linear functions are functions that when we graph them, we get lines like this. So when we're looking at these examples of linear functions, the first thing that we're going to see very often is being asked for the average rate of change. Average rate of change is just a fancy way of asking for the slope. So on a graph, when we are trying to find the slope, we're going to take any 2 points. Lattice points would be the easiest ones to use. And when I say lattice points, I mean points that go through at integers. So like I wouldn't want to use this point because I don't know exactly where that is. You know what I mean? But lattice points will help because then you can just count boxes. So we're going to remind ourselves that slope is rise over run.
College.
Yeah, listen.
And sorry, Alexis, you were unmuted for a second there. So slope is a rise over run. And so first of all, I want to point out that this line is increasing, which means that my slope will be positive. So lines that are increasing have a positive slope, lines that are decreasing have a negative slope. And then we're just going to count boxes for rise over run. So to get from this point to this point, how far up do I have to go? And then how far over do I have to go? So it's 1, 2, 3, 4, 5 boxes up. And then 1, 2, 3, 4 boxes over. So that makes my slope 5 over 4. The rise was 5, the run was 4. And so my average rate of change is 5 over 4. They asked for a reduced fraction, so they're looking for 5 over 4. Now, if we are asked for average rate of change between 2 points, then we're just going to use the slope formula, which I think we've already reviewed once this semester, but let's talk about it again. So my slope formula is y2 minus y1 over x2 minus x1. So I'm going to label my points here, x1, y1, x2, y2. And so my slope will be -7 minus -1 over -6 minus 2. And so then -7 minus -1 would become -7 plus 1, which is -6. And -6 minus 2 will become -8. And then they're asking for a reduced fraction. So I can reduce numerator and denominator by -2, which would make it 3 over 4. I have like the very beginnings of a headache right here. So usually if I press on it, it doesn't hurt as bad, in case you're wondering what I'm doing. I'm not like trying to Professor X mind read you or anything. So, thank you for laughing, Christian. So, if we are asked whether or not a table represents a linear function, what we're looking for is a constant rate of change. Okay, a constant rate of change. So what we're going to do is we're going to find the rate of change in between each set of points and make sure that that rate is constant. So to find the rate of change, we're basically going to figure out, okay, what is the rise and what is the run? So for example, here from 9 to -1, it wouldn't rise, actually, it would fall. So we would say -10. And then from 0 to 5 would be a run of 5. And so then the slope would be -10 over 5, which is -2. From -1 to -11 is -10. and from 5 to 10 is 5. And so again, we have negative 10 over 5, which is again negative 2. So far, my rate of change is constant. It's negative 2 both times. So let's do this one more time. From negative 11 to negative 21 would be negative 10. And then from 10 to 15 would be 5. So we again have negative 10 over 5, which is again negative 2. And since all of those are the same, then that means this is linear. If even one of them is different, then it is not linear. And I also want to mention that it's my most reduced version that matters. So like if I would have had a negative 20 over 10, that would have reduced to negative 2 and you would have still counted it. Okay?
Oh, no boyfriend. Got a boyfriend?
So here, from negative 5 to a positive 10 would be positive 15, right? We go up 15. From 0 to 5 is 5. And 15 over 5 is 3. From 10 to 25 is 15. From 5 to 10 is 5. So that's 15 over 5, which is 3 again. From 25 to 40 is 15. From 10 to 15 is 5. 15 over 5, which is 3 again. So I'm going to say yes, this one is linear as well. Okay, let's keep going. From 16 to 31 is 15. From 5 to 10 is 5. So here I get a slope of 3. From 31 to 60 is 30. From 10 to 20 is 10. But 30 over 10 means I have still a slope of 3. From 16 to 76 is 15. 20 to 25 is 5. So we're back to 15 over 5, which is still 3. So this one is linear as well. From 9 to 34 is 25. From 0 to 5 is 5. 25 over 5 is 5. From 34 to 9 is 75. From 5 to 10 is 5. 75 over 5 is 15. From 109 to 234 is 125. From 10 to 15 is 5. 125 over 5 is 25. You see how here my 3 slopes are not the same? So that means this one is not linear. So you have to have a constant rate of change in order for the table to be considered linear. Here, if we have a graph and we are asked for slope-intercept formula line, let's remind ourselves that slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept. So we're going to find our slope the same way that we did before, keeping in mind that you can use any 2 lattice points. So how about this one right here and this one right here? I also want to remind you of something I said earlier, and that is that when a line is falling, its slope is negative. So the slope of this line should be negative. The line is decreasing, so it has a negative slope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my slope is that I went down 10, 2, 3, 4, and over 4, which would reduce to negative 5/2. And now someone in my last class asked, what if I had chosen different points? Well, like we just said, slope of a line is constant. So any 2 points that you would have picked when you counted the boxes, you would have had a slope of negative 5/2. And so then my y-intercept, it crosses the y-axis right here at 0, 1. So that makes my b value 1. And so you want to say the equation of this line is y equals negative 5/2 x plus 1. But of course, we're dealing with more, so the answer is not that simple. When you're dealing with a question like this, you need to use their function notation. So here, it doesn't say y and x, it says p of r and r. So I need to write this, when I put it in this box, it has to be p of r equals negative 5/2 r plus 1. If you write it in this way, you're going to get it wrong. And then you're going to be sending me a message on more saying, my answer is right, what's the problem? And then I'm going to respond to you and say, you used the wrong letters. Okay. So if you are given a table or a set of points and asked to find the slope, you're going, or asked to find the equation of the line, excuse me, you're going to start by finding the slope, just like we did before. You can pick any points for x1, y1, x2, y2. I'm just going to use the first 2 points because the numbers are the smallest. So this will be x1, this will be y1, this will be x2, this will be y2. And so then my slope is a negative 126 minus a negative 36 over 30 minus 10. And so a negative 126 minus a negative 36 becomes negative 126 plus 36, which is negative 90. And 30 minus 10 is 20. And negative 90 over 20 will reduce to negative 9/2. Once you have the slope, you're going to take the slope and any point and plug it in to point slope. So x1 and y1 are my same x1 and y1 from when I found the slope, and n is your slope, and then you leave y and x. So this would be y minus a negative 36 equals negative 9/2 x minus 10. So minus a negative 36 becomes plus 36. And then the next thing I'm going to do is distribute this negative 9/2. So it'll be negative 9/2 x. And then what you're going to do is take the negative 10, multiply it by the numerator, divide it by the denominator, or you're going to put in your calculator what is negative 9/2 times negative 10. So negative 10 times a negative 9 would be a positive 90. Divided by 2 would be 45. And then since we're going for slope-intercept form, I'm trying to get the y by itself. So I'll subtract that 36, 9. But then we know more and it's variables. It always has to be a little extra. So this would actually be f of t equals negative 9/2 t plus 9. Okay. So given an equation, remember that the number being multiplied by your variable is your slope, and the number by itself is your intercept, but they're going to want you to write that as a point. One of the easier questions that we'll do. All right, and so for this next one, if this is my equation, then my rate of change is 0.02. And then this is asking me for the units of my rate of change. So make a note for yourself that units of slope are always y per x, or 1y for each x. So here they're telling me that my x value, so that's where my n is minutes, and my y value is dollars. So then this would be 0.02 dollars per minute. And then your units of your initial value are always just whatever your units of y are. So for this second one, I would say the initial value is $11. I don't know what my daughter's doing out there, but she is happy. Okay, so I put this question on here not because I feel like the math is terribly difficult, but because I feel like it gets a little tricky in the wording. So here, if we're saying the initial population is 6,100, then that's going to be 61,000, excuse me, then that's going to be my B value. And it's been growing by 2,200 people per year. So that's going to be my slope. That people each year is a dead giveaway that I'm dealing with my slope. Just like in the last one, the monthly charge per minute was 0.02. Anytime you see that, you're going to know that you're dealing with your slope. So then the equation of this line would be P of x equals 2,200 x plus 61,000. And so then here they want to know, when will the population reach 91,500? So P is my population, so I'm going to replace P with 91,500, and I'm going to solve for x. I'm going to subtract the 61,000. And then I'm going to divide the 2,200. Now, I want to talk about this answer because this is years since 2013. So we know that 13 years, or 2003, excuse me. So we know that 13 years later is 2016. And I feel like this would make you want to round up, but don't. Because they're asking you during which year will the population be 91,500. Now this 0.86 just means that it's going to be close to the end of the year. It means we're looking at like October or November, but that's still within the year 2016. Okay. If you round this up to 14 and round your answer up to 2017, it's going to be wrong because this means, like I said, like October of 2016, but still 2016. All right. So whenever you're dealing with a question like this and they want to know within what year, you're only concerned with the integer part of your answer, because this just tells you what part of the year, but that's irrelevant because I just want to know within which year. Okay. And then the population in 2012. Okay, well, if we're starting in 2003, then 2012 would be 9 years later. So that's x equals 9. And we'll just plug 9 in. And I'm just going to put that in my calculator just like you see it. So in 2012, the population will be 80,800. All right, and then last but not least, here we have clothing business finds it's a linear relationship and it can sell 5,000 shirts at $34. Guess what, my friends? That's just a point. My input is 5,000, my output is 34. 6,000 shirts at $31. And then this essentially becomes the exact same question as the one when we had the table before, where I'm just going to say, okay, so we'll find the slope. 31 minus 34 over 6,000 minus 5,000 would be -3 over 1,000. This time they're asking for decimals, so that's going to be -0.003. And then I take the slope at a point and I plug it into point slope just like I did before. So y minus 34 equals -0.003 x minus 5,000. And so again, just like before, I'm going to distribute. So -0.003x. -0.003 times -5,000 is going to be a positive 15. And then we're going to add the 34. And my final answer here, 0.003x plus 49. Except that they want p and n. So my actual final answer here would be p of n equals negative, I forgot the negative sign down here, 0.003 n plus 49. Okay, so that is what I had for you tonight. We have about an hour left.